what is the first question? The first question is asking you to check if the limit exists. So you have to use the H method whenever you have to find whether the limit exists or not. So this is written like a piecewise function. So it is negative of x minus 2 when x is less than equal to 2. And it is equal to x minus 2 when x is greater than equal. So this is very important to know, okay, in the context of next year as well. So here I am writing limit x tends to 2 minus f of x. Okay, because we are talking about left hand and we are talking about values of x which are less than 2, I will take this. So this is limit x tends to 2, and I'm going to take negative x minus 2 over x minus 2. Okay, now x is approaching 2 from the left hand side. So again, let me just draw quickly here a diagram. So this is 2, this is 1, this is 3. So when x is approaching 2 from the left hand side, where is x? X is here. Okay, so I can write x as 2 minus h, where again, I told you about delta. You can write delta or you can write h. So what is x? X is, so let me just write over here. This is negative. This is 2 minus h minus 2. And here I have 2 minus h minus 2. Okay, so what did I do? I replace x with 2 minus h. And what is h? H is a very small interval between x and 2. And we want that interval to become 0. So as x becomes very close to 0, x will become very close to 2. That is the logic. So limit of h tends to 0. What do I have over here? I have h over negative h. Now, can I cancel this? I can, but why can I cancel it? Because I know that it is not 0. Remember, in math, this is not permitted. You can't cancel that. But if you have something like 5 and 5, the answer is equal to 1. So what do I write? As h tends to 0, h is not equal to 0. Okay. So because h is not equal to 0, I will get this as negative. And now when I'm taking the limit, what do I get this equal to? Okay, let me call this as the left hand limit. So therefore I get the left hand limit as negative 1. Okay, now that we have got the left hand limit, we will now find the right hand limit. So right hand limit of x tends to 2 minus f of x. And we are talking about numbers to the right. That means we are talking about x being somewhere here. So now that x is greater than 2, we can write the function as just x minus 2. So what will I write here? This is limit x tends to 2, x minus 2, x minus 2. Limit h tends to 0. So let me take you back here again. So because x was to the left of 2, x was smaller than 2, so that was 2 minus h. Now over here, x is to the right, x is bigger. So that is 2 plus h now. I will substitute that. So I get 2 plus h minus 2, 2 plus h minus 2. So limit h tends to 0, you get h over h. Since h tends to 0, h is not equal to 0. Okay, I can continue this. I get limit h tends to 0 is 1. Taking the limit, I get it as 1. So let me write the right hand limit is equal to 1. Now, since the left hand limit, which is equal to negative 1, is not equal to the right hand limit, therefore we conclude the limit does not exist. This is limit x tends to 0, 1 upon x. So here what we take, limit x tends to 0 minus 1 upon x. Now when x is approaching 0, from the left hand side, I will write x as 0 minus h. So this is the left hand limit. I can write it as h tends to 0, 1 upon 0 minus h, limit h tends to 0, negative 1 over h. Now, obviously, you should know how the reciprocal function looks. If you don't, you should at least think what is happening over here. X is becoming very, very small. So what will be the reciprocal of x become? It will become very, very big. So just think about it. Okay. When x is equal to 2, 1 over x is 1 upon 2, that is 0.5. When x is equal to 1, 1 upon x is equal to 1. X is equal to 0.1, this is 10. 0.01, that is 100. So as x is becoming 0, 1 upon x is becoming infinite. But because of this negative sign, what do we get? It is equal to negative infinity. So we have the left hand limit equal to negative infinity. And now if I do the right hand limit, so right hand limit is limit x tends to 0 plus, what do we write this as? H tends to 0, 1 upon 0 plus h, limit of h tends to 0, 1 over 0. And that answer for the right hand limit is positive infinity. Again, left hand limit is not equal to the right hand limit. Therefore, limit does not exist. Okay. If a student wish to explain it graphically, you may do so, but do a decent job of drawing a graph. So this is x, this is y. So the reciprocal function looks like this. Okay, you can bring it a little closer. Yeah. So here you can see that as x is coming closer to 0, okay, so I can call it as x tends to 0. And here the function is going toward positive infinity. And when x is approaching 0 from the left hand side, the function is going towards negative infinity. So they are definitely heading in the opposite direction. So they are not the same and it does not exist. Okay, so this is our next sum in which we have to find as x approaches 0. What does the function sine of 1 over x approach? Okay, so first we have just now seen that as x become closer to 0 from one side, 1 upon x approaches infinity. Okay, and I want to make another point. Okay, for that, let me just take you back to the Excel sheet. So here I'm taking x and I'm plotting here 1 upon x. So let's say x is equal to 0.1. Now after that, x is 0.2. Okay, so this is equal to 1 upon this value, and that is 10. And then you have 5, 10 and 5. So that means if I have a value 0.12, for example, okay, I'm getting 8.33. If I get a value, anything, 0.17, for example, I'm getting 5.85. The point I'm trying to make is there is a interval of 5. Now, what does a interval of 5 indicate? Students, understand one thing. If you think about a sine wave, so this is 0 degree, this is pi, this is 2 pi, and pi is 3.14 something, okay? And this will be 6.28 something. So when the value of 1 upon x goes from 10 to 5, the value of sine goes from 0 to 1 and back to 0. And then it will go, if this interval instead of 5, it is 6.28, it will go from 0 to 1 and then minus 1 and 0 again. The point I'm trying to make is it is not approaching a particular value. It is oscillating, it is fluctuating between 1 and minus 1. Okay. One more way to understand that is to actually see how the plot looks. So here this is sine of 1 upon x. And here you can see how it is oscillating here. So here you can see that the sine of 1 upon x is not settling for one value, but it is oscillating continuously between +1 and -1. So the answer to the question, this question is the limit does not exist. Okay. So algebraically, as in when I showed you the Excel sheet, I told you that a small value of x makes a big change in 1 upon x. And whenever x value, delta x value changes by approximately 6.28, then the sign of 1 upon x will make one complete wave. And as you're approaching zero, the change in 1 upon x is massive. Okay. And therefore, the function keeps oscillating between 1 and -1. So, therefore, we say the limit does not exist. Okay. What you're supposed to write is as x approaches zero, 1 upon x approaches infinity, and the function sine of 1 upon x do not approach a particular value, but it keeps oscillating between +1 and -1. Okay. So that means if the limit needs to exist, what value p should take? So if the left hand limit, then when x is taking value less than 1, so that is 2px plus 3 is equal to the right hand, that is 1 minus px squared. Now, when it is not the same function or it is a piecewise function, we can now directly take the limit because it says that the limit exists. So limit will only exist when the left hand limit and the right hand limit exist. So we can take the limit here, taking the limit. What is the meaning of taking the limit? In place of x, you put that number. So this is like a generally calculus students have this question that when initially in the chapter we said that x is approaching 1, that means x is very close to 1, but x is not equal to 1, then how are we substituting x as 1? So it is like saying you are plugging a value very, very close to 1. Okay. And I showed you in this Excel sheet also, like, when I took more number of decimal places, it was not actually 1, but it was very close to 1. Okay. Like in this case, if I reduce the number of decimal places, you can see that it just gives you 1. So that is the logic. You are plugging 1. And what do you get? You get 2p plus 3 is equal to 1 minus p. So you get 3p is equal to -2. You get p as -2 by 3.